In this video, we're going to talk about power functions. Each of these is a power function. I've got 5 examples here. Then I have 2 examples that are not power functions. Can you see the difference? Notice none of these up here have something that's plus or minus. Also notice none of these up here have a variable as an exponent. So these 5 are power functions. These 2 are not. I will give you some very specific examples of power functions in class tomorrow, but first we're going to do some work with them. So power functions, not power functions. Now let's work on defining them. So a power function only has one term. It is a monomial. A power function cannot have a variable in the exponent. By definition, a power function has the form y equals kx to the p power, that's the generic, where k and p are constants, and k and p can be positive, negative, or fractions. Okay? So, are these examples of power functions? If yes, I want you to state k and p. So let's look at it. Here's example A, 13 cube root of x. So we've got to do some simplifying. So 13 cube root of x can be simplified to 13 times x to the 1/3 power, because remember cube root is the same as the 1/3 power. And we can simplify that more to 13x to the 1/3, which means that yes, it is a power function because it is a monomial and it does not have a variable in the exponent. So k would be 13 and p would be, and p would be 1/3. Remember that it's written in this form, y equals kx to the p. Look at b. G of x equals 2 times x plus 5 squared. Now, if we simplify this, it becomes 2x squared plus 20x plus 50. That is not a power function because there's way too many terms. Look at c. H of x equals x plus 3 times x minus 3 plus 9. Now, at first glance, it doesn't look like a power function, but when we multiply everything through, we get x squared minus 3x plus 3x minus 9 plus 9, and when we cancel everything out, we end up with just x squared. So yes, this is a power function. We have a k value of 1 and a p value of 2. Alright, u of x equals square root of 25 over x cubed. So if we simplify that, whoops, this should be x cubed. We end up with square root of 25 over square root of x cubed, which can be simplified further to be 5 over x to the 3/2, which we can rewrite as 5x to the 3/2, because remember that's the same as saying 5 divided by 1 over x to the 3/2, which we can multiply times x to the 3/2 over 1, because dividing by 1 over x to the 3/2 is the same as multiplying by x over 1. So that just becomes 5x to the 3/2. So now we've got a monomial, and so yes, it is a power function, and k is 5 and p is 3/2. What about this? V of x equals 6 times 3 to the x power. So no, this is not a power function because we have a variable in the exponent. So these were just some examples of terms to see if they are power functions. Okay, so let's look at some power function graphs. Okay, so recently we've talked about square root graphs and cube root graphs and absolute value graphs. So now, looking at these 2, the blue is the graph of 3x to the 4th power. You know what an x squared graph looks like. So an x to the 4th graph is just going to be a little wider. Same thing's going to happen, x to the 6th, x to the 8th. They're all going to just become a little more compressed. They're all going to become wider. Anything with an odd number up here, cubed, 5th, 7th, they're all going to start looking like this. These are all examples of power functions. So this blue one is 3x to the 4th, This green one is negative 2x to the 7th. Now in your notes, it asks you to find two more power functions that match, look sort of like these. You can do this in a calculator. If you don't have one, we can work on this in class tomorrow. You can probably Google it, but you're going to play around with it. I kind of just gave you a hint. Same thing down here. So this blue one represents x to the 1/2. Remember that x to the 1/2 is the same thing as square root of x. So this should look very familiar. This green one represents x to the 1/8, which is the same thing as the 8th root of x. This doesn't look familiar because this isn't a function that we talk about a lot. But notice they are familiar. So you should be able to imagine what something in between would look like. So again, you're supposed to be able to come up with what two other power functions would look like that are similar to those. Why don't you work on those for class tomorrow, and we'll talk a little more about it.